Yes. Good evening, all of you. The questions, as we expected, I can surely say that no question has come either not discussed in the class or come in our marathon examining series we had. We have 50 NEET model examinations we have conducted. So all the questions either we have taught in the class or has come in our examination series. Okay, we can directly start. Question number 1 from the chapter 7. A wheel is rolling without slipping. For a body rolling without slipping, the velocity at the center point, will be same as V. So this point we can say O. At the point O, velocity is V, and the point Q, bodies rest for a moment. For a moment, body is at rest, velocity is 0, and at the point P, it is twice V. That we have taught you a number of occasions. And so velocity at P is greater than velocity at Q. And repeat, velocity at P is 2V, velocity at Q is 0. Therefore, velocity at the point P is more than velocity at the point Q. Answer 1 is correct. Go to the next question. Now, this is the transitions given. N2 is equal to 3 to N1 is equal to 2. That is the first Balmer line, least energetic, largest wavelength. So A is transition, that's first Balmer line, H alpha line. In the first Balmer line, the wavelength is maximum, so that is coming to be 656.3 nanometer. So A matching with 3. Now, next energies from transition 4 to 2. 4 to 2 is next energy, that is coming to be 486. Then C 5 to 2, next energy 5 to 2 or next higher wavelength, that is coming to be 434. That is C matching with 3. C matching with C is 5 to 2. 5 to 2, C matching with C matching with 2, correct. C matching with 2. D 6 to 1, least energetic, so maximum energetic, and wavelength is minimum, that is 1. So A matching with 3, B matching with 4, C matching with 2, D matching with 1. So answer is 1. Next question, simple question, a PV diagram given. We have to calculate the work done in the path BZ. Everybody can do the answer in 5 seconds. BC is isochoric process. Work done is 0. So answer is 4. We go to the next question. A simple circuit is given. Circuit EMF is 10 volt. And internal resistance is 1 ohm. Effective resistance is 4 plus 1, that is 5 ohms. Circuit current will be 10 by effective resistance, that gives you 2 ampere. And what is the question asked you? What will be when connected, you have to calculate the terminal voltage. V is equal to E minus I into R, 10 minus 2 into 1, that is 8 volt. So answer is very simple, 2. So very direct question without confusing anybody, everything given very clearly. Now, come to next question. Here, in the transformers, very simple, number of turns in primary to secondary is 1:2. We have to find the voltage in secondary, and simple relation voltage in secondary to voltage in primary is number of turns in, voltage in secondary to voltage in primary, Vs by Vp is equal to Ns by Np. Np by Ns is given to be 1 by 2. So this will be is equal to 2:1. Very direct question without any confusion. So the answer for that question is coming to be 6th question is 1. We now go to the next question. Here, question needs somewhat calculation. This is a question from ray optics. We have to go through the calculation. What things given to you? Yes, angle of incidence is given to be 30 degree. Yes, angle of incidence is 30 degree. So here, this case, the angle of refraction we can take, angle of refraction. So this will be 90 minus R because this is a normal. This is 90 degree. So this will be R. This will be 90 minus R. And this is 90 degree. So all angles have been easily marked. That you have to do in the first attempt. Angles are marked. Now tell me, we have to calculate refractive index. From first surface, mu is equal to sine 30 divided by sine R. Sine 30 divided by sine R. Sine 30 is 1 by 2, it will be 2 sine R. We got it? Now come to the second surface. Again, you have to make mu. So if you have to consider the reversibility aspect, angle of incidence should be taken as sine 90 degree divided by sine of 90 minus R. Because here, if you have to consider the light coming from the air to the material of the prism, so this is to be taken as angle of incidence for the second case. This is angle of refraction, that is 1 by cos R. So we got first surface, mu is equal to 1 by sine 2R. We can equate it. So we can calculate that 2 sine R is equal to cos R. That gives you tan R is equal to 1 by 2. Therefore, we can find that tan R is equal to 1 by 2. So we can make a simple diagram. This is R. This is 1 by 2. This will be root 5. And tell me what is mu. Mu is equal to 1 by cos R. 1 by cos R. From this diagram, cos R is equal to 2 by root 5. 1 by 2 by root 5. That comes that mu is coming to be root 5. So I repeat, first surface, this is the picture. Second surface, this is the picture. Both are mu. We equated it. We got tan R is equal to 1 by 2. From that we calculate cos R. Cos R is coming to be 2 by root 5. And mu is equal to 1 by cos R. This is coming to be root 5 by 2. This is somewhat a difficult question. We need calculation in this series. Okay, we go to the next question. Come on, simple question, quantities which have same dimensions. Everybody knows it. And the moment you see the question, everybody will say that strain and angle are without dimension and your answer is 4. We go to the next question. You know, a thin flat circular disc of 4.1 centimeter is placed gently on the surface of water. Surface tension of water is 0.7. You know, for water, we are considering the angle of contact is theoretically speaking 0. Therefore, you know, the force which is trying, it's along the perimeter it is acting. So that will be acting down along the perimeter. Total force will be 2 pi r into t. 2 pi r into t. 2 pi r into t. And substituting the values of everything given, radius given, surface tension given, your answer is coming to be 19.8 millinewton. Answer for the 9th question is 4. Answer for the 9th question is 4. Now we come to the 10th question. Listen, and here question is not a difficult thing, but this is an assertion reason type question. We have to involve a calculation. So the first statement, potential at any point on the axial at a distance r from the center of a dipole moment. So potential at any point is given by 1 by 4 pi epsilon 0 p cos theta divided by r square. P cos theta by r squared. 1 by 4 pi epsilon 0 is 9 into 10 to the power of 9. The magnetic moment is given to be, how much magnetic moment is given to be? Its dipole moment is 4 into 10 to the power of minus 6. Cos theta is 1, theta is 0, r is 2, r squared is 4. So when you are calculating, potential is given to be 9 into 10 to the power of 3. 9 into 10 to the power of 3 plus or minus depending upon that. So this will be correct option. Assertion is given correctly. Now come to the reason. They in the beginning they made a mistake. What the mistake we have made? The potential is given as 1 by 4 pi epsilon 0 into twice p by r squared. We have calculated the potential is 1 by 4 pi epsilon 0 into p cos theta by r squared, and cos theta as being 1. Here they have taken 1 by 4 pi epsilon 0 into twice p by r squared. Of course, reason is wrong, very wrong. So assertion is true and reason is 4. Of course, your answer is coming to be the second option. So in that point of view, except that one question of ray optics, all the questions are very easy as we have expected, as we have done in the class. Okay, we'll be dealing with question number 11 to 25. Okay, and the trend is same. Similar type of questions are asked. Come on. Yes. Now, a monochromatic light in double slit experiment replaced by white light. We are told a number of occasions that no dark fringe, central fringe will be white and bright, and other fringes are colored. Different fringes are of different width. All the things we have taught you a number of occasions. So the correct answer here is there will be a central bright white fringe surrounded by the colored fringes, no dark fringe. So simple answer, answer 2. We go to next question. Atoms are electrically neutral. We are told in the class, the person who is going to explain the atomic structure, he or she has to answer 3 things: stability of atom, neutrality of atom, and finally emission of radiations from the atom. So tell me what is the first statement? That's correct statement. And second statement, atoms of each element are stable and emitting its characteristics. The radiations emitted by an atom it's a lock and key test for the atom, isn't it? It's DNA fingerprint, we can say. So it will emit its characteristic radiation. So both statement 1 and 2 are correct. 4 is option. Next one, maximum elongation of steel, the elastic limit, steel is Young's modulus is given. So the simple question, now we can find that elongation, we have to calculate extension. Extension is given by force into length into y into a. Force by a, we can take it as what? Elastic limit, E into L by A. E into L by A. Isn't it? E is given 8 into 10 to the power of 8. Young's modulus is given, Y is given 2 into 10 to the power of 8. Length is 1 meter. You will be easily getting the answer as 4 millimeter will be getting. It's very direct question. Only one thing we have to make it out. F by A, we have to take it as elastic limit. Come on. Next question. And we have told a number of occasions the characteristics of the the solar cell we are drawing on 4th quadrant. Yes. So Solar cell characteristics lies in the fourth quadrant. That is the correct answer. And in forward biasing, the current is constituted by majority carriers, and reverse biasing, current is constituted by minority carriers. So see the second option, in reverse bias PN junction diode, current is in microampere. It's due to the majority carrier. That's the wrong option. Minority current is constituted by the drifting of what? Minority carriers, and forward current is due to the diffusion of the majority carriers. This is a very common question, I think, before we coming to the new pattern of semiconductor physics. In Kerala entrance is very commonly asked a number of occasions. Forward current is due to the majority carriers, diffusion, and reverse current is due to the drifting of minority carriers. So answer is what? Yes, assertion is correct and reason is wrong. Next one, particle is moving in a uniform speed in a circular path, maintains uniform speed. Who is continuously changing? Velocity is continuously changing. Therefore, direction is changing, velocity is changing. Acceleration's magnitude only constant. So acceleration is also changing the direction. So constant acceleration is a wrong statement. Constant velocity is a wrong statement. Varying velocity and varying acceleration, that is a correct statement. Both velocity and acceleration are varying. Both are varying. Both are varying. Yes. Next. Yes. Now come to that velocity of light in free space. That is question number, and this. No, stop it. This question number മാറി വന്നു. ഇത് 17. If c is the speed of light in free space, correct statement about photon among the following are: energy of photon is h nu is correct, speed of light c is correct, momentum of photon is what? H nu by c, E by c, that's correct. D, photon electron collision, both energy and momentum are conserved, that is correct. Photon possesses positive charge, photon is neutral. So again, this is a direct pick from NCERT book. So A, B, C, D are correct. Option is 1. 16th question answer is 1. Now coming to the next question. Come on. Two bodies A and B of same mass undergo completely inelastic collision. Body A moves with velocity v1, body B at rest. So we have to ask the ratio of velocities. So initially only who was moving? Body A was moving. So initial velocity is V, we can take it. Then after collision, both the bodies stick together. They will move together with the velocity v2. So v2 will be v by 2. v2 will be v by 2. Isn't it? v2 will be v by 2 because the total mass of the system is 2m. Velocity is, momentum will be mv. Therefore, velocity of the second case of the system v2 will be v by 2. So v is to v by 2, or answer is 2 is to 1. Answer is 1. Now coming to the case of variation of 1 by lambda square and its kinetic energy. Lambda is a de Broglie wavelength. Simple question. Look, de Broglie wavelength is given by h by root of 2me. So we have done many times, but we want in terms of lambda square. Tell me, lambda square is h by h square by 2me, or E is proportional to 1 by lambda square. So the graph between 1 by lambda square and E will be a what graph? Straight line graph. This is the answer. 3 is the correct answer. Okay. Simple question. Nothing difficult here. Next question. An unpolarized light beam strikes a glass surface at Brewster's angle. Light incident Brewster's angle. We know Reflected light ray is completely plane polarized. Reflected light ray will be completely polarized. That is the correct answer. We have to find the correct answer anyway. Both reflected and reflected light. That is the wrong answer. The reflected light ray will be completely polarized and refracted ray will be partially. Reflected light ray will be completely polarized. The refracted light ray will be partially polarized. So first one is wrong. Refracted light ray is completely polarized is wrong. Second is wrong. Third is clearly correct. Reflected is completely polarized and refracted is partially polarized. So third option is correct. Third option is correct. Now we go to the next one. 19th one. At any instant of time, so simple question. Tell me, force is 5 Newton, velocity is dx by dt, that comes to be 2. Therefore, power is equal to force into velocity, that comes to be Newton watts. In SI system, it is asked the 10. So, simple question, answer is 4. Now we come to the next question. Yes. Next question. Yes. A tightly wound coil of radius 10 centimeter carries a current of 7 ampere. The magnitude of the magnetic field acting will be coming to be 4.4 milli. Direct question. So nothing to be worried about it. Mu 0 I by 2R. Substituting the values, will be getting 4.4 milli Tesla will be the answer. We go to the next question. Then moment of inertia of a thin rod about an axis passing through the midpoint perpendicular to the rod and is 2000 grams centimeter squared. Length is 400 grams. Then what is the length of the rod? Length of the rod. This is the case, moment of inertia about an axis passing through the midpoint and perpendicular to it, ml square by 12. That is given to be how much? That is given to be 2 in grams per centimeter squared. We want L square. That is 12 into 2100 coming divided by how much? 400 grams. So simple calculation, this is coming to be 72. I think it's coming to be 70. This is 2400. 2400. This is coming to be 72. L is root of 72. That is coming to be nearly 8.5 centimeter. Answer is 4. Now we go to the next question. Yes, Bob whirled in a horizontal circle by means of a string with an initial speed of omega rpm, and the tension in the string provides centripetal force. Tension in the string provides centripetal force. What is that? M omega squared r. M remains same, r remains same. What happened to the omega? Omega becomes 2 times. Therefore, centripetal force will be M omega squared r into 4. Answer will be 4t. Initially it was t, now it is 4t. It's a very direct question. Now, next one, the match the following. Diamagnetic substance, its susceptibility is between 0 greater than sky greater than -1. -1 for perfectly diamagnetic substance. Okay. Now, ferromagnetic. So, 1 A matching with 2. A matching with this diamagnetic matching with 2. Correct. A matching with 2. Then ferromagnetic, chi much greater than 1. B matching with 3. A matching with 2. B matching with 3. Paramagnetic, C matching with 4. Yes. And D non-magnetic, chi is equal to 0. D matching with 1. So A matching with 2, B matching with 3, C matching with 4, D matching with 1. Answer is 4. Answer is 4. Yes. Now Next question, 25th question it is. In the following circuit, the equivalent capacitance between terminals A and terminal B. This is equivalent to a balance bridge. We cannot call it as a balance bridge. Balance bridge, we are talking for a what? Talking for a resistance network. This is a capacitance. One thing, due to this arrangement, if I mark the point C and D, we can find that potential difference between C and D will be zero. So we don't consider both the terminals of the capacitor of same potential. Potential difference is zero. We don't count it. These two will be in series. Effective capacitance will be 2 by 2 is equal to 1. These two will be in series. Effective capacitance will be that. Then 2 and 2 will be parallel. So effective capacitance will be 2 microfarad. The answer is 4. Answer is 4. That's about this lap of questions. Again, we'll be completing quickly all the questions. So wait for few minutes.
Now we shall continue, my dear children. Now come to our next question, 26. Question is in the following circuit, the equivalent capacitance between the terminals A and B. You can see that very well from the diagram. It is very clear that this is Wheatstone equivalent in capacitor circuit, because these two are all identical. These are all identical, and for this is equipotential point. But for this, if I say C and D are equipotential, and therefore we can remove this capacitor from here. Remove this. Then these two are series. 2 and 2 series, 1 VF. 2 and 2 series, 1 VF. 1 and 1 parallel, therefore 2 VF. Therefore, its effective capacity is equal to 2 VF. Now, we shall go to the next question. In a very basic problem, we have met many number of times through our material. Now, the original force 10 Newton is applied to the block A, as in figure. The mass of the block A and B are 2 kg and 3 kg respectively. The block slide over frictionless, and therefore whatever force applied is used for acceleration, and the steady ready-made formula is there with you. Now what is the contact force here? Here the contact force F1, if I say, the formula is that applied force into fractional mass in front. Fractional mass in front. Now simply applied force is equal to 10 Newton into fractional mass in front, 3 by 5 is equal to 6 Newton. So the answer is equal to 6 Newton. Option is 2. Shall go to the next question. Now this is a nuclear radioactivity decay process is there. You can see that original parent is given. In the nuclear emission stated above, the mass number and atom number are the product give the final data. What is the mass number and atomic number? You know, in nuclear reactions, mass number is conserved, atomic number is conserved. That is what we are going to apply. Here you can see that X82, 290 on alpha decay. You got a Y. In alpha decay, mass number decreases by 4, so it is equal to 286. And the atomic number decreases by 2, it becomes 80. Then beta decay, positron emission, E plus, and therefore you can see that what happened. And again there is E minus, that will cancel out. Here you can the mass number remain the same, which one set. A proton become neutron, mass number remains at 286. A proton become a neutron, and therefore this becomes 79. Now beta decay, the positron emission, beta decay, electron emission. Then what about? That is our P. P, it becomes 286. There is no change for the mass. But here this increases by 1, is equal to 80. Now again 1 electron. again one electron emission is there, and therefore what happens, this remains the same, 286 Q, 286. Now electron emission, and therefore it increases by 181, and therefore the number 28681, and accordingly the option is, which is the question number, finally is 28681. Next, the vernier caliper for the n plus 1 divisions of the vernier scale is coincide with the n division of the main scale. If one main scale represented by 0.1 millimeter, the vernier constant, that means the least count. What is the least count? You know basic formula for least count, value of one main scale division by number of division on vernier. Now substitute, directly substituting value on main scale division 0.1, and the answer is there in centimeter, and therefore 0.1 millimeter converted into centimeter is equal to 0.01 centimeter by number of division of the vernier. There are vernier n plus 1 division of the vernier scale coincide. So there are n plus 1 divisions are there on the vernier. Our number of division on the vernier is n plus 1. It's called 1 by 100 centimeter. Therefore, the 1 by 100 n minus 1, the option is equal to 1. Go to the next question. 29. You are given a equation. Find sine pi t plus some pi by 3 something. May it represent the motion of a particle executing SHM. Say simple harmonic equation. Amplitude and time period of the motion respectively. You know the coefficient of the trigonometric function, that is equal to, we are given yx is equal to 5 sine pi t plus pi by 3. Now the coefficient of trigonometric function is equal to 5. That is our amplitude. Simple comparison. So amplitude A is equal to 5 unit. Next one, then what is omega? Coefficient of time is omega. Of omega is equal to pi. But instead of omega, what is asked there in the problem? The time period. Time period t is gone by 2 pi by omega. Equal to 2 pi by pi. Equal to 2 seconds. So amplitude is 5 and time period is equal to 2. And the option is equal to 1. Go to the next question. In the above diagram, a strong bar magnet is moving towards solenoid 2. This is solenoid 2 and this is the solenoid 1. And I am going to draw that here. This is the core, and here it is marked like that. Curling is like this behind this core, and therefore the connection is going like this. This is the way it goes. And finally, this is the end. Here the end B. And this wire is on the other side of this core and come like this. This is the way it goes. And finally, this is the end A. Now we can see that this bar magnet is moving away from here and going to enter into this solenoid. And the question is, the direction of the induced current in the solenoid 1 and that of solenoid 2 respectively are. There, look at this solenoid. As far as the solenoid is concerned, you can see that north pole is moving away and the observer is the magnet, and therefore the magnet has to look back to the solenoid. And in that case, as north pole is moving away, and therefore this by electromagnetic induction principle try to prevent the motion of the north pole away from this pole. And therefore, this is going to act as another dipole or a bar magnet, definitely with this face as south pole. Then only it will pull this north pole from moving away from it. And therefore, this end must act as a north pole. And therefore, from looking from here, this face of the solenoid must act as a north pole, and therefore the current must be, you know that when you look into a solenoid, if the current is anti-clockwise, north pole, if it is clockwise, it is south pole. Now you know this has to act as a north pole and a south pole, and looking from here, the current must be clockwise. Clockwise mean the current must be clockwise, mean like this. So it must go like this. It must go like this. Then only the current is clockwise looking from here. And therefore, this is the direction of the current from A to B. From A to B, as far as this coil is concerned. Now look at this one. A south pole is going to enter into that one. This will, by electromagnetic induction principle, try to prevent its arrival. Prevent arrival, there must be repulsion. For with this phase of the solenoid must act as a south pole. And to become a south pole, the current must be, again, the current must be clockwise. The current must be clockwise. The clockwise means there you can see that looking from here, it is clockwise. Looking from here, it is clockwise. Clockwise mean here, if the current is like this, then from look, if the current is like this is clockwise current. Therefore, it must be like this. And therefore, the current is clockwise looking from there. There from C to D. Therefore, here it is A to B. There it is C to D. It is C to D. Again, look. Looking from here, the current is, current is clockwise. Clockwise mean this is the clockwise direction. Therefore, it must be like this. Says it is the clockwise. That is anti-clockwise. Sorry. If you look like this and the current is like this, it is anti-clockwise. It must be clockwise. So sorry, we have to replace this one. I'm going to move this one. Now this must be again clockwise. Clockwise mean it must be, this is anti-clockwise, this is clockwise. This clockwise means like this. Both ways it must be south pole. And therefore, looking from here, this must be a south pole. Looking from here, this must be a south pole. So here is anti-clockwise, clockwise current. Here also must be clockwise current. And the direction is from here A to B, whereas here D to C. And therefore, the option is A to B, then D to C. That is 4. The option is 4. So you are the observer, and looking here, it is south pole. Looking from here, this is south pole. For which the current must be clockwise, therefore direction must be like this. So this is one of the difficult problem there. Now next question. 31. Now following the truth table expression of the output y, there is no need of going for a Boolean expression, algebra, etc. Analysis not at all required. Look here, this is the output, and that is the inverted value of this b. If b0 is 1, this is 1 0 0 1 1 0, and therefore what is y? Y is equal to b bar. Simply y is equal to b bar, and therefore the option is equal to. Next, a wire of length L and resistance 100 ohm is divided into 10 equal parts. Therefore, now we have got a 10 equal resistors is having 100 by 10 is equal to 10 ohm. Or we have got 10 ohm resistor segments. The first 5 bars are connected in series like this. 10, 10, 10, 10. 5 into 10 is equal to 50 ohm. while the next 5 are connected in parallel. Now this all together 10, 10, 10, 5. 5 by 10 by 5 is equal to 2. These two are connected in series. 50 plus 2 series. Therefore, equivalent is equal to 50 plus 2 is equal to 52. So effective resistance of this arrangement per their problem is 52 ohm. 52 ohm. So option is equal to 1. Next one. The output Y of the given logic gate is similar to the output of AND gate. No. There is something. Output of a gate. That's okay. Output of a gate. What is this gate? That's okay. Now you can see that this is not gate. This is a NOT gate. And this is one of the method by which a universal gate can be converted into a basic gate. And this is an AND gate. And AND gate is simply, remember how a universal gate can be converted. And NOT gate, this is NOT gate. The output of these two NOT gate is given to NOR gate. Therefore, this is an AND gate. Now, instead, you use a shorted NAND. Here you use a shorted NOR. Both are NOT gate. Therefore, ultimately, the gate is an AND gate. Next question. A thin spherical shell is charged by some source. The potential difference between the 2 points C and P. C is the midpoint and P is the point on the surface shown in figure. Then we have to find the potential difference. For a charged shell, potential on a surface and any point inside are say equipotential points, and therefore potential at C and potential at P are the same. So the question is, what is the potential difference? 0. So potential at C equal to potential at P, where Vp minus Vc is equal to 0. Any point inside, need not be at center. Any point inside, the potential is same as on the surface. So potential difference is 0, and hence the answer potential 0. The option is equal to C. Next question. The mass of a planet is 1/10th of a Earth, and its diameter is half that of Earth. Then accelerated due to gravity. Now accelerated due to gravity on the surface of Earth is equal to G(m) by r square. On this planet, G planet is given by G. Mass of the planet is 1/10, so m/10. And radius of the planet is half that of Earth. Therefore, it's equal to r/2 whole square. Equal to 4/10 Gm by r square. This is our G. Equal to 4/10 G. And this is equal to, if you take this is equal to G is 10, equal to 4. Or that is equal to 3.92. If you take 9.8, the answer is equal to 3.2 meters per second square. So the option is equal to 3. Next question. The minimum energy required to launch a satellite of mass m from surface of Earth of mass m and radius r in circular orbit at an altitude of 2r from the surface of Earth. Now, initially, the body is on the surface of Earth, radius r. There, the total energy is the potential energy. The total energy at this point is given by minus G m by r. Now, what we have to do, you have to take that into a height, which is equal to on the surface of Earth and radius r into a circular orbit at an altitude 2r. Circular orbit altitude 2r. Therefore, radius of the orbit is equal to 3r. And we have to convert that into a satellite there. If you simply take the body to that point, the potential energy easily minus G m by 3r. The potential energy. But if this is the potential energy, what is the total energy there? Total energy is equal to minus half, which is simply, it is half of the potential energy there. It's equal to minus G M by 6R. Here the total energy is equal to minus G M by R, and here the total energy is equal to minus G M by 6R. Now, what is the energy difference? That is the work done. So, the energy required or work done on energy required is equal to change in minus G M by 6R minus of minus G M by R. We are not simply raising that body to that height, but we are converting that to a satellite. And therefore, we have to take into account the total energy, not the potential energy, total energy of the satellite there. The problem says so. Now, take the difference. It's equal to G M by R, equal to 1 minus 1 by 6. Is equal to 5 by 6 G M by R. So that is our answer. Now we came up to question number 36. Now next question is 37. Question read like this. A small telescope has one objective focal length 140 centimeter and eyepiece focal length 5 centimeter. Then the magnifying power of a telescope for viewing distance object. That means for normal setting. For normal setting, magnification M is given by for telescope F4 by Fe. F4 is given to you, they are 140. 140 by Fe is given there 5. The sum calculation is 28. So the option is equal to 1. Now next question. 38. Velocity time graph that is plotted there, and that is given to you. And there you can see that here the velocity increases during this interval, and that slope is a constant. And slope of velocity graph is acceleration, and this is positive acceleration up to this time. Then during this interval, the slope is 0, no acceleration. And during this interval, the same slope but negative, and therefore negative slope. And the slope is the acceleration, 0 acceleration, then negative acceleration. Now look at here, this is the situation. Here, up to this, no acceleration, constant acceleration during this interval. And during this interval, no acceleration. During this interval, negative acceleration and a constant. So the option is equal to this one. So option is equal to 2. Now 39, next question. 39. Now the problem lies, two heater A and B have got power rating of 1 kilowatt and 2 kilowatt respectively. Those two are first connected in series and then in parallel to the same power source. That is, applied voltage is same. Then the power output of these two cases ratio. Now when the two are connected, first connected in series like this, these are the two power systems connected in series and same voltage is applied. This is P1, this is P2. Then what is the effective power when they are connected in series? In series, P1, P2 by P1 plus P2. So this is the basic formula, and therefore substituting P1. So 1 into 2 by 1 plus 2. So 2 by 3 kilowatt. That is in series. Whereas when they are connected in parallel like this, P1, P2, same applied voltage. The total power P parallel is 1 by P1 plus P2. It's equal to 1 plus 2 is equal to 3 kilowatt. Next one, we have to find the ratio. In first case, 2 by so PS by PP equal to 2 by 3 is equal to 2 by 9. So the option is equal to 1. But now you can see all these problems were already done in our material, and that is given to you through our question papers, direct and simple one. Now coming to the next question. Question number 40. The force is defined by F is equal to AT square plus BT. Act on a particle one given time t. The factor which is dimensionless if A alpha and beta or A and beta are constant is. Now you can see that here it is given F is equal to, given that F is equal to A alpha or alpha t square plus beta t. Since this is force, this is force, this is force. But dimensionally you can see that alpha t square and beta t same dimension. So we can equate because both represent force. Therefore you can say alpha t square dimensionally equal to beta t. Or alpha t is equal to beta. Cancel out one t. Then which is dimensionless. Their ratio must be dimensionless. Their ratio must be dimensionless. Therefore, what you can write, alpha t by beta is dimensionless. Single one, therefore dimensionless. So alpha t by beta. So option is 1. We shall go to our next question. 41. Forty-one. 10 mega capacitor is connected to 210 50 hertz source as shown in figure. The peak current in the circuit. We know the voltage in AC circuit given there is RMS value, 210 volt RMS value. Now we can calculate the RMS current. This is simply a capacitor loader circuit. Capacitor loader circuit. Then what is the current? IRMS. IRMS equal to VRMS by set, where set is the total impedance. Here the impedance is contributed by only by capacitor. So here Z is equal to XC is equal to 1 by C omega. Equal to 1 by C 10 mu or 10 into 10 raised to minus 6 into omega 2 pi n 2 pi into 50 is equal to 10 raised to 5 by 100 pi. This is equal to by pi. This on calculation, the value on calculation. This is our Z value. Now question is IRMS. Substituting IRMS, VRMS is equal to 210 by Z value 10 raised to 3 by pi. This is IRMS. But question is, you see the peak current, I0. Question is the I0. Therefore, I0 is equal to IRMS into root 2. Therefore, it's equal to 210 into root 2 by 10 raised to 3 into pi. Numerical calculation definitely needed, and this value on calculation is equal to 0.93x. So option is equal to 1. Doing this, you get the answer like this. Next question. 42. A metallic bar, Young's modulus, 0.5 into 10 raised to 11 Newton per meter square, and the coefficient of linear thermal expansion 10 raised to minus 5. Length 1 meter and area cross section 10 raised to minus 3 meters square. Heated from 0 to 100 degrees centigrade without expansion or bending. Then the compressive force, that is thermal force generated. Thermal force formula directly that is there with you, F is equal to Y A alpha delta theta. Like straight away you have to substitute and get the answer. Thermal force Y A alpha delta Y. Y is given there 0.5 into 10 raised to 11 into area cross section is given to you. Area cross section is 10 raised to minus 3. Unit is correct into coefficient linear expansion, thermal expansion 10 raised to minus 5 into delta theta, the change in temperature, that is 0 to 100, where it is 0 to 100 degree. 100. And this value simply calculate. This calculation yield the value 50 into 10 raised to 3. The value is equal to 50 into 10 raised to 3. That is the value. Simple calculation. get the answer. So option is equal to 1. Next, 43. A parallel plate capacitor is charged by connecting to a battery through a resistor. If I is the current in the circuit, then the gap between the plate. Now, suppose this is the capacitor and this is the charging cell. In a conductor, there is conduction current IC, and through the dielectric, there is displacement current ID. And since circuit, as long as it's live, till it completely charges or it blocks DC, you can say that this IC and ID are the same. IC is equal to ID. That is our answer. Same direction, same sense. And therefore, option displacement current magnitude equal to I flows in the same direction as I. So there is, the option is equal to 1. Next question. 44, you can see that choose the correct circuit which can achieve the bridge balance. Now, bridge balance mean P by Q must be R by X. Now, we have to see out of these 4 options, in which one that possibility is there. Because one of the branch contains a diode. Diode conducts only when it is forward biased. Otherwise, the resistance in that branch become infinite. And therefore, look at, you can see that this is reverse bias. And here it is 5 ohm parallel with the diode, and the effective resistance must be less than 5. To balance this circuit, here is 10 and this is 10, about 10 by 10, 1. Here it is 15 and the ultimate resistance in this branch is 15. But here, if it is so, it is forward bias, okay. But here effective resistance less than 15, not possible. Same is the case with here, reverse bias, not possible. Now come to this option. Here option, you can see that this diode is forward bias and therefore this will conduct. And if its forward resistance is 10 ohm, it is conducting. And if its forward resistance is 10 ohm, altogether in this branch, it is 15 ohm. Then 10 by 10 is equal to 15 by 15, possibility for balancing. And therefore option is 4. Option is 4. Go to the next question. 45. 45. A sheet is placed on a horizontal surface in front of a strong north pole. A force is needed. And for what purpose force is needed? See, here there is a north pole. There is a magnetic field here. And we have got, in this horizontal plane, we have got a plate. If it is a conducting, if it is a magnetic, ferromagnetic or magnetic plate, at once we can say that this will act as another dipole. Magnetism will be induced on it, provided it is a conductor. Provided it is a magnetic. If it is magnetic, it will act as another dipole. And there will be south pole here and north pole here. And therefore, between them, there will be force of attraction. If it is magnetic. And therefore, to hold it there, you have to apply force. And therefore, that option is correct. Then you hold the sheet there, if it is magnetic, that option is correct. Hold the sheet is there, if it is non-magnetic, no force is required for that. This option is not valid. Now, move the sheet away from the pole with the uniform velocity with conducting. When you move like this, move out, definitely there will be a D current. It's a metal plate, conducting plate, and when you move, there will be a D current. And definitely there will be force. If you try to move, if it is a conducting one, and if you move due to the presence of the D current, there will be force. And hence, there will be force. If you move sheet away from the pole with the uniform velocity, if it is conducting, means there will be the D current effect and force is needed. Move the sheet away from the pole with the uniform velocity if it is both non-conducting or non-polar. No, non-conducting. There is no possibility for that. And therefore, you can see that A and C of option is 1. Option is 1. Next, 46. Go through the question. In the place of a parallel plate capacitor connected to a battery are moved closer to each other, then now we can see this is the capacitor plate connected to a battery like this, and it is said that it is moved closer. You know, capacity of the capacitor is given by epsilon 0 A by D. Now, when you move them closer, D decreases. When D decreases, C increases. So, by this activity, definitely C value, capacity C value increases. Capacity increases. Now, since it is remain connected to the battery, voltage applied across the capacitor remain the same, V constant. Charge Q is equal to CV. C increases, therefore Q increases. Our charge increases. Our charge on the stored increases. That is true. Energy stored in the capacitor decreases. Let us see. What is the energy? Energy, you know that, half CV square. Energy is equal to half CV square. Here V is a constant, C increases. Therefore, U increases. But in the next option, it is energy stored in it decreases. Now, capacity increases. That is true. Here you see. Ratio of the charge on the capacitor, ratio of the charge to potential. Q by V. Q by C, V is equal to C. And the capacity increases. We already told that. Here, ratio of the charge to potential remains same. Wrong. Charge by potential is capacity. Capacity increases. This is wrong. Now, the product of charge and voltage increases. Charge and voltage. What about the charge and voltage? Here, charge and voltage Q V. The product of charge and voltage Q V. V remain the same. But what about the charge? Charge increases. Therefore, that product value also increases. So this is true. So now ACE. ACE. That is true. So option 1 is correct. Next question, 47. Now there is a little clarity more needed for this question. Let us go to the question. The following graph represents the TV graph of an ideal gas, where T is the temperature and V is the volume. At the 3 pressures, P1, P2, P3, compared with those of Charles law, represented by dotted line, that is the way to Charles law, it is enough. What about this graph? There is a deviation is there. Why this deviation is there? Because pressure are not the same. That's okay. What we expect by Charles law there? You know, by ideal, say ideal gas, and therefore we can write the equation. PV is equal to for 1 mole RT. Therefore, if you make a T equation, T is equal to P by R into V. This is a straight line equation. This is the slope. The slope of the graph is equal to P by R, where R is a constant. Or we can say slope of the graph proportional to slope of the graph. If you conduct the graph for different gases, if you are conducting the experiment for same gas for different pressures, Vt, then there is a deviation is there. Still, you can see that slope is larger when pressure is large. The experiment is done at the different pressures. Therefore, we can say whichever gas has got larger slope, that has got larger pressure. If you look into the graph, you can very well see that slope is largest for this one. This is the largest. The next slope P2. Next slope is P3. And the slope means P, pressure. You can very well see from the graph slope of P1 greater than that graph I mean, or pressure P1. is greater because slope is more, P1 is more. P1 greater than P2 greater than P3. Slope proportional to P, and therefore P1 greater than P2 greater than P3. And see what is the option for that. 47. P1 greater than P2 greater than P3. Therefore option is equal to 3. 48. The property which is known an electromagnetic wave traveling in free space is that energy density electric field is equal to energy density of magnetic field. That is true. They travel with a speed equal to root 1 by mu 0 epsilon in free space. That is true. They originate from charge moving with uniform speed. That is wrong. Accelerating charge generate electromagnetic wave. This statement is wrong. They are transverse in nature. That is true. A wrong statement is option 3. Next. 49. An iron bar of length L has magnetic dipole moment M. We did many number of problems like this. It is bent in the middle of a length such that the two arms make an angle 60 degrees with each other. Magnetic dipole moment of the new magnet. Earlier, suppose this is the length and dipole moment is M. The pole strength of this magnet is given by M by L. And what we did, we bent here and we got a magnet like this. So that this is L by 2, this is L by 2, this angle is equal to 60 degrees. Pole strength remains the same. Our pole strength is P. Now, then what is the linear length? Linear distance. The linear distance between this north pole and south pole is equal to L by 2 because it's an equilateral triangle. So this is L by 2. Pole strength is M by L. With new dipole moment M dash equal to pole strength into new linear separation L by 2. P is given by M by L. So M by L into L by 2. This will cancel out. You got M by 2. So M by 2. So the option is equal to 1. Okay. Next question, 50. Now, if the last one, if the mass of a bob in a simple pendulum increases thrice, its original mass, and its length is made half of its original length, then the new time period of oscillation. Up to that we did. But here only a mathematical thing is done, that's okay. If the oscillation is x by 2 times the original time period, then what is the value of x? Now, you know the time period of a simple pendulum t is given by 2 pi root of L by G. And there is no room for mass of the bob in the expression for time period. Well, you made mass twice or thrice, time period remain the same. But in our problem, it is said that the length is out. Half the original length. The new time period is given by t dash is equal to 2 pi and root of L by 2 by G. Now dividing this is question number 1, in this question number 2. If we divide, you can see t dash by t. If you do t dash by t, or you can write, instead of that, you can write like this, take root 2 out, 1 by root 2 into. Instead of doing this, t dash is equal to 2 by 1 by root 2 into 2 pi root of L by G. 2 pi root of L by G by our equation number 1 is t. Therefore, t dash is equal to t by root 2. Now what they did, it is given that that is x by 2 time original time period is this 2. Therefore, you have to write t dash is equal to x by t. Therefore, x by 2 times original time period. Therefore, t dash, that t dash is equal to x by 2 times original time period. So, substituting for t dash here, you can write x by 2t is equal to t by root 2. T will cancel out. Then x is equal to 2 by root 2 is equal to root 2. So, our answer is equal to root 2. Option is equal to 1. Now, that finishes the physics portion. And as you see, almost all the questions except 1 or 2 They are all straight away direct problem in which we have to substitute the formula and record data. There is no need of physical logic. So I hope that you did well. Thank you.